Hello everyone, it's Miss Redmond here again with your Christmas Science at Home video. This time round our material is this stuff, which is bicarbonate of soda. Now, before you do any of these experiments or activities, you need to ask permission from the grown-ups at home, and you might also need a little bit of help with some of the experiments. Alright, here is a list of all the things which you will need to have. So pause the video now while you write any of those down. So there's lots of different names for bicarbonate of soda. The most scientifically accurate one, or the most modern one, is sodium hydrogen carbonate, but it's also called sodium bicarbonate, bicarbonate of soda, and baking soda, not to be confused with baking powder. And there's the chemical formula down the bottom. So if you are year 7 or above, which is all of you, you should be able to tell me how many atoms in that formula and how many atoms of each element. Okay, next thing to tell you is I'm doing this at home, so you might hear washing machine noises and you might hear my children in the background. All right, so our first experiment is, as you read, exploding Ziploc bags. I've got 3 different temperatures of water. Let me try and get all of these in the shot at the same time. There we go. Okay, that's better. Okay, I've got 3 different temperatures of water. I've got ice, I've got room temperature, and I've got hot. I don't have a thermometer at home, so I've just had to do it like that. You may have a thermometer at home, but I feel that's unlikely. Okay. In each of these Ziploc bags, I've measured out 200 mils of vinegar, normal distilled malt vinegar, white vinegar, but this experiment will work with any acid. This one's cheap and clear, so it's not going to make too much mess, because we are going to explode these bags. So, I've measured out also 2 teaspoons of sodium bicarbonate into separate thingies, and I'm going to pop them all in and we'll see what happens. So I pop it in, close up the bag, pop it in, close up the bag. Oh my gosh! So you can see that the hot water one exploded way before the other 2, even though I put those in first. So you should be able to tell me why using the particle model. And if you were going to be more scientific about this, you could time it with a stopwatch. And that way, if you also had a thermometer at home, you could then draw a graph of temperature against time taken to explode. Woo, that was exciting. So these 2 haven't exploded yet. I wonder if, well, they should do eventually, because they should produce the same volume of gas. So I'll just keep talking. There's other curriculum crossovers with this experiment. You could write it up like a diary entry. That would be a crossover to English and literacy. You could do it in another language. That would be a crossover for MFL. You could film it on your camera in slow motion, so that would be a crossover to media or photography. If you're really brave, I suppose you could add food colouring and see if that made it pretty. What else can I tell you about this experiment? Okay, so vinegar's acidic because it's got acetic acid in it. It's dilute acetic acid. So when that reacts with sodium hydrogen carbonate, it produces carbon dioxide and water. So carbon dioxide is the gas that's filling up these bags. You can see that. That is absolutely full of gas and just ready to explode, but it still isn't doing it. So if you're in year 8 or above, possibly 9 or above, you should be able to tell me how carbon dioxide and water might relate to the cells topic. Alright? Now, sodium hydrogen carbonate is used a lot in baking, so you could also tell me what it's used for in baking. Oh well, the hot water one worked really well. Okay, I'm going to clear up all of this stuff and then I'm going to show you the next two experiments. Ta-da! The magic of television. Okay, so here's one I prepared earlier. I've made two versions of honeycomb. With one, I used baking soda, sodium hydrogen carbonate, and with the other, I used baking powder, which has sodium hydrogen carbonate in it, but it's also got other stuff. And I also burnt it a little bit by accident. Whoops. So I'm going to show you a little clip now of me making it, and then I will come back to you. Okay. Oh wow, look at that. Oh my gosh. Smells really bad now. That's incredible. Okay, that was me there with my marvellous non-panicking cooking skills. As I mentioned in the other video, cooking is chemistry. Okay, so that is a crossover between this video and food tech. And also, something I forgot to mention with the exploding bags, obviously that's a crossover with the Year 7 particles topic because it's gas pressure that's causing those bags to explode. All right, back to our honeycombs then. You can see that the baking soda one has risen a lot more than the baking powder one, although that could be because it's slightly burnt, because burnt sugar is going to have different properties to non-burnt sugar. So let's try and get these out and see how they've gone. And obviously I chose to do this because it's Christmassy, because it's food. I basically associate any food with Christmas. Christmas is just about eating way too much. Oh God! This is a nightmare, guys. Okay, so this is the baking soda one. If we have a look, you can see the size of the carbon dioxide bubbles that are formed in there. And you also might have noticed it keeps sticking to stuff. It's very sticky because, no, I was going to say something that's wrong. It's not because of that. Anyway, sodium hydrogen carbonate, when you heat it up, does a reaction called thermal decomposition, which is relevant for Year 10 science. And that reaction produces carbon dioxide and water. So that's what makes it sticky. So you've got sugar and water. You know that something's sugary and wet, it's all sticky. And then if we look at the baking powder one, you can see that the carbon dioxide bubbles are a lot smaller. So that's why it's puffed up a lot less. And like I said, it's burnt. So the properties of the sugar might be different because it's all burnt up. Cool, but you can vary your honeycomb recipe any way you like and see what effect it has. All right, so that's experiment 2. Experiment 3 is testing the strength of your honeycomb. So I'm hoping at some point it's going to break. So I've got 2 objects of equal height. I'm just using baking trays. And I'm resting my honeycomb on those 2 objects. I could probably go a bit further apart. Okay. If we're being very scientific, we should measure the distance between these 2 baking trays and make sure it's the same for both sets of honeycomb. All right, so the next thing that I'm going to do is place something on top of my honeycomb, because I'm going to add coins to this bowl until the honeycomb breaks, and I don't really want to put the dirty coins on top of my nice honeycomb, so I'm going to eat it. Probably.
Is it going?
It's going. Can you hear it?
It's going to right.
Whoa! Was that good? It broke. Okay, now I'm going to weigh the coins. Okay, so I've got my coins that I used to break the honeycomb with. Now I've got my kitchen scales, so just turn them on. These are really similar to the ones we have at school. The ones that we have at school are more precise because they measure to more decimal places. So I'm going to put my whole bowl of coins on there and see how much it weighs. Wow. 1.915 kilograms, or 1,915 grams. You can't see that on the screen, can you? Okay, so I'm going to clear this stuff up and we'll do the other one. Okay, so here's my second honeycomb, the one that I use baking powder for, not baking soda. Now, there's something I've done which makes this not a fair test. I would like you to tell me why that is. Okay, and something else I'm going to do, because that one took over 1 kilo to break, and this one's got smaller bubbles, I'm thinking it's going to be stronger. So I'm going to start off with nearly 1 kilo of rice in this Tupperware. Now maybe you can tell me. So I've used a container here that's got, the base has a different surface area and a different shape to the previous one. So maybe you can tell me how that might affect my results. It's not even making any cracking noises.
No.
No.
Now?
Yep. Now, can you tell me if that is going to be an accurate result or not? But that was interesting. Okay, what else do I need to tell you? Yeah, so there's a lot of... What's that? Yeah, there's a lot of things I've done between those two parts of the experiment that is going to make it an unfair test. So maybe you can tell me what they were and how they're going to affect our results. So we should weigh the second lot. Yeah. So I've turned my balance on and I press the on button. The on button also says tare. Tare just means setting something to zero, setting the balance to zero. So that's tared. I'm going to put that on and that is 2.120 kilos, or 2,120 grams. Okay. And since we've, our year sevens, my year sevens rather, have just done the forces topic, you could work out what the force was that was needed to break those two honeycombs. All right. Now, if you feel like doing any of these, please send me photos and videos of what you've done. You could write it up as a report. I've put some report pro formas on the Show My Homework. You could send me a PowerPoint, whatever you like. Just if you do something, please, please, please let me know about it. Last time around, there were a couple of people who were surprised that I gave out prizes, and they said they would have done it if they'd known that there were prizes. Well, it's not about prizes, is it? It's about the science. But there will be prizes and college points for anyone who enters. So please get in touch, tell me what you think, and have a lovely Christmas. Bye bye.